Hi everyone, it's Tutoring Tuesday time, and tonight we are focusing on subtraction, and the only strategy we are going to focus on is decomposing. So when you think of that word decomposing, I want you to think of a number, and I want you to think about breaking it down. So you have the number 10, and you can break it up into 5 and 5, right? 7, 3, all that. That's all first grade. But when you start talking about multiple digits, so like a double digit number, like for example 23, you're decomposing that into place values. So you're decomposing it into 2 10s and 3 1s. So we're going to work on just decomposing. And what does that look like in first grade all the way to fourth grade? And we're only focusing on subtraction. And the reason why I decided to just focus on subtraction is because it seems to me the pattern that I hear over and over and over again is subtracting is so difficult. And truly it is, right? Students are naturally more inclined to add, right? Adding just seems a little more natural. And so when you ask them to subtract, it's like the opposite end of your brain, but really we need to teach them that within addition, we can learn subtraction. And so it's really important for them to see that as well. And that's going to be maybe in the upcoming weeks. But like I said, tonight we're just focusing on decomposing. We're starting in grade 1 and we're working our way up to grade 4. One thing I want to be very clear too is the fact that when your kids bring work home, so they're bringing home homework or they're bringing home ideas, and I'm sure you ask them all the time, like, "Ooh, what did you learn in school today?" And of course their natural reaction is nothing. But then when you start probing, they might say something like, "Oh, we subtracted numbers today." And so when they show you what they do, or you have a piece of paper that they bring home, you're like, what are they doing? This is not subtraction. So when we think of subtraction, our instinct goes right to the standard algorithm. We put the larger number on top, smaller number underneath, and we just go about our, nice little way in procedure and crossing off and making certain numbers the right number because we have to regroup, and we don't know really what we're doing, but we do it anyways. So when our kids are introduced to subtraction, they are not being taught the standard algorithm, and the purpose of that is the fact that they need to understand exactly what they're doing. And without the place value understanding, they will never ever understand the standard algorithm unless you break it down for them. And that's exactly what we do in grades 1, 2, 3. Got it? All right, here we go. So I'm going to flip you around and we're going to start in grade 1. All right, here we go. All right. So once again, my high-tech video. We are subtracting. I have little pumpkins in the background just to keep my paper down. Thought I'd be a little festive. So in grade 1, we are, and I just put like little notes for you to know that grade 1 really focuses on subtraction within 20. And we also go into subtracting multiples of 10. So we're going to do both together today. So with grade 1, just normal subtraction within 20. They start with numbers within 10. So they might have something like 7 minus 2. And notice how I'm writing it horizontal. It's really important for them to see that what subtraction means instead of stacking it. It's really important for them to talk about what's actually happening. So I start with 7. I'm taking away 2. And that that phrase, take away, is really important because within subtraction, we are truly taking things away, right? When we subtract something, we're taking it away. When we subtract money from our bank account, we're taking it away. And so when we teach kids how to subtract, we really want to let them know that this is our whole number. This is what we start with. This is the part we take away. And our job with subtraction is to figure out this missing part of what's left over, okay? So let's talk about some strategies. So this is not decomposing yet, but I'm going to show you exactly how to do this in a moment. Okay, so first grade typically has counters. They count them out, they put 7, and they physically take them away, okay? That's easy. However, if they were to draw a picture could look like this. So they could draw 7, and they could physically take 2 away, and then they can count that the answer is 5. The other thing, or the other strategy, is they might start seeing my whole is 7, the part I'm taking away is 2, and I'm trying to find this missing part. So if I had 7, 1, 2, 3, 4, 5, 6, 7, and I know part is 2, so 2 is here, what's my remaining part? And that's 5. Now, what's awesome about this strategy is then they can use addition that they're very comfortable with to check their work. So they can really see that 2 and 5 make 7, 7 minus 5 is 2, 7 minus 2 is 5, and they start seeing this wonderful fact family that we have. Okay, so this is truly what grade 1 focuses on. Now, when we talk about subtracting multiples of 10, this kind of gets a little dicey. So let me show you what this means. So they really take their understanding of how to subtract with 17 minus 2, and they bring it over to subtracting multiples of 10. Now, when I say multiples of 10, just count by tens, and that's what you get. You talk about 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100, okay? Now, one thing I just want to be very clear is that if we always say that when you subtract, you get a smaller number, we are actually doing a disservice to our kids. When you are subtracting, you are in fact taking a quantity away. That's for sure. But that quantity really indicates, are we increasing in value or decreasing in value? Because eventually in middle school and high school, when they start talking about negatives and you had a -7 and you take away a -2, what's actually happening, right? So really we want to talk about just the nature of subtraction, not as we're always getting smaller, but rather the action of, if I have 7 and I physically take 2 away, how many am I left with? Thinking of that part-whole relationship. Same thing with multiples of 10. I apologize, I'm going to grab my manipulatives. So these are base 10 blocks that your students will start seeing, or your kids will start seeing. And what we start with is we start having them build. And this would be very similar to if they build 7, but this time they're building 70. So 10, 20, 30, 40, 50, 60, and 70. Okay? So if the problem that we're solving is 70 minus 20, the students actually build the whole quantity of 70, same thing, part, whole. This is my whole 70, and I'm taking 20 away. 10, 20. And what am I left with? 10, 20, 30, 40, 50. The same thing goes with simple subtraction. I call this simple subtraction just because we always bring it back to home base. Kids feel comfortable doing this, and then all of a sudden you throw this at them and they're like, whoa, this is my whole. I started with 70 total. This is my part I'm taking away. And your job with subtraction is to determine what part are you still left with. So if my part that I took away was 20, what's the part that I'm left with? And they can count with physical objects. Now, if you don't have these objects at home, which I'm guaranteeing the last time I checked in someone's household that's not a teacher, they don't have these wonderful base 10 blocks that have 10 little ones that are glued together to make a 10. So something that you could use as a physical object would be a pretzel rod, or you can show your kiddos that they can draw a 10 as just a simple line. So 10, 20, 30, 40, 50, 60, 70, okay? So that is my total. That's my 70 total, and I'm taking away 20. I no longer have those 20, and then they can count up 10, 20, 30, 40, and 50 left. So truly what they learn in school with the physical objects of base 10 blocks, you can also do at home in more of a representational form. Okay, so really that's what we do in grade 1. We really just focus on if we have a single digit number and we take another single digit number, what are we left with? And then we start going into the subtracting multiples of 10. Now here's the deal. One thing to kind of keep in mind with anything when it comes to subtraction is we don't always want to say, obviously, the number's getting smaller. We don't always want to say we start with a bigger number. We always just want to use the terms what is our whole? What did we start with? And we started with 70, okay? What are we taking away? So let me put this into context. I had $70 in my wallet. I spent $20 at Starbucks, which is not too far from the truth these days. How much do I have left? And that is 50, okay? And make sure they're bringing it back to context, so $50. But really, we want our kids, instead of saying you always start with a bigger number, I want you to really reinforce what did we start with in the context. So this is my whole that I'm starting with, and I'm taking a part out of that. Because what's going to happen is that all of a sudden, and I don't mean to freak you out at all, but all of a sudden they get into higher grades, and they go from 20 and they take 70 away, and the solution is negative 50. Well, what happened to the rule that my grade 1 teacher or grade 2 teacher taught me about the bigger number always goes first? In this situation, now granted we do know that this is a negative, but in this situation, just looking at it, that is not the biggest number here, right? Truly, once they start seeing it, they do see that, but I don't want us to just assume that we always start with a bigger number, okay? Don't worry about that, grade 1 teachers, but just worry about what's my whole, what's the part I'm taking away, what's the part I'm left with. All right, let's migrate into grade 2. This is where it gets a lot of fun. Okay, so I'm gonna put a little squiggly line so we can separate the grade. This is the summer break, and then we're jumping into grade 2. Okay, so in grade 2, we are really focusing on fluently subtracting within 100. And when I say fluent, I don't mean that they know right off the top of their heads 23 minus 17 or 72 minus 51, okay? What I'm saying is that they have an effective strategy to arrive at the solution. Okay, so let me give you an example. So grade 2, subtracting with 100. Say if I started with the total of 54, and I'm asking you to take 22 away, okay? Notice, I'm still writing my problems horizontal. I'm never stacking them, ever, 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 because I want them to see I'm starting here. This is my action. I'm taking away 22, okay? So if this is my total, this is my whole that I'm starting with, I want to represent my whole. So I do this using tens and ones. So similar to what we talked about in grade 1, we would represent this with tens and ones. And you have to, let me just apologize for myself for reaching over because I have to grab my ones. Okay. So if I had 54, so I'm going to represent this. Let's see, 10, 20, 30, 40, 50, and 4. Okay. So let me show you 54. Okay. Remember, we're always using the term, we're starting with the whole and we're taking a part away. So what's the part we're taking away? We're taking away 2 tens and 2 ones. 2 tens and 2 ones. This is where the decomposition comes into place, guys. 2 tens and 2 ones I just took away. What am I left with? I'm left with 3 tens and 2 ones, which we know is 32. So the part that we're left with is 32, okay? So now, what does this look like when we have to regroup? So let me start with 54 again, but this time, I'm gonna make this down here. So let me start with 54 again, but this time we are going to take away 27. So once again, look how I wrote it. It's horizontal. We always want to talk about the action that's happening in math. So we start with our total. The action here is we're taking away, we're removing 27 of them. So within 54, we have 27 to remove. Okay, we have plenty of them, but we just might not have enough in each place value to do so. So let me talk about that. So once again, I'm going to do my building of my total, which is 54. Okay? Now students start seeing that, if I'm taking 27 away, I can take away 2 tens. No problem. There's my 2 tens. Okay? But what happens when I get to my ones? I don't have enough. So this is where students, I'm just going to put this over here, if they were to stack, they automatically reverse this and see it as 7 minus 4 is 3, and 5 minus 2 is 3. This is where the misconception lies, okay? So we do not show them that yet, okay? All right. So we're going to start with 54, which we just did. We're taking 2 tens away, okay? But the problem lies in I don't have enough ones to take my 7 away. I only had 4 ones in 54. So what do I do? Where do I get those 7 ones? And that's where students can then decompose or break down or regroup this 10. And they break it up into 10 little ones. Okay? So let me get 10 little ones. Hopefully I have enough. And if I don't, just work with me. I might have to draw them. So let me draw them for you. So I'm going to break this up. I'm going to take a hammer and I'm going to take off each one of these and break it down into 10 little ones. 1, 2, 3, 4, 5, 6, 7, 9, and 10. Okay? So I just took this 10 and I just decomposed it. Okay? So now I can take 7 ones away. 1, 2, 3, 4, 5, 6, 7. And I'm left with 4, 5, 6, and 7. So I have 2 tens, 7 ones, and my answer is 27. So truly, when you're subtracting, you really want to make sure that you're physically showing students what exactly you're doing, because if you automatically stack and put the larger number on top of the smaller number and all that jazz, we're going to start seeing misconceptions coming. But if we put it side by side, we talk about the situation and we talk about the action. If we talk about this action of 54 and we build 54, right? And we talk about this action of taking 27 away. We're physically taking 20, and then that's where they realize, oh my gosh, I don't have enough ones to take away. Okay, so really talking about the action is huge in grade 2. And remember, fluently within 100 means that what they're going to eventually be able to do is take 54 and take 22 away by decomposing it. So they might do something like, and don't let your students or let your children just explain to you what they're doing, but they might do 54 minus 20, which is 34, and then 34 minus 2, which is 32. We can still see that we took 22 away. We just decomposed it, okay? Don't be afraid, guys. Don't be afraid that it looks different from how we learned. This strategy will in fact allow students to eventually start seeing the patterns that occur naturally in math, okay? So really this decomposition truly helps us when we move on to 3rd grade. So let's talk about 3rd. Now granted, I want you guys to know that grade 2, we do start subtracting within 1,000, but truly we don't really focus on it until grade 3. So let's do that. So let's do 452 minus 141. Okay? So what do we do here? This is where it gets complicated, right? So students have had a chance to build in 1st and 2nd grade. They've had a chance to decompose, and they started decomposing in 2nd grade with 1,000. And so now what they're really truly doing is decomposing these numbers. Now remember, the algorithm is not taught until grade 4, folks. We're not stacking and adding anything. We're not stacking and adding or subtracting anything. We are still going horizontal. So we still talk to our kids, and we still start talking about, this is my whole. I'm doing the action of removing 141 away from that whole. So this is the part I'm taking away. And my job is to determine what part is remaining. Okay? So let's do this. So really the decomposing when it comes to this really lies in place value. So I'm just going to, for the sake of this video, abbreviate hundreds as H, T as tens, and 0 as ones. So students start building 400, 5 tens, and 2 ones. I do X's for ones. Some people do circles. Some people choose to do, I just do X's. It's just been easier for me. Now we're going to do the action of taking 141 away. So I'm going to take the action of 100, 4 tens, and 1 1 away. Okay? I highly encourage double two-color markers so that they can actually see the physical action of taking that 141 away. If you noticed, every time I went into the place value, I said 100. I said 4 tens, and I said 1 1. Whereas if we do this, we lose that because we say 2 minus 1 is 1, 5 minus 4 is 1, 4 minus 1 is 3. Nowhere in there did you hear me say 300, 1, 10, or 1, 1. Now, I know that seems really silly to you all, but truly, eventually, this will start breaking down. This procedure that we're teaching our students will eventually start breaking down if they do not have the foundational knowledge to be able to subtract. So now what they can do is they can count up their hundreds, they can count up their tens, they see their ones, and they're able to say 311 is left over. Okay, so stack and carry, easiest to learn. For us, okay, so now I am going to show you exactly how to do this with decomposition. So I'm going to use the same kind of problem, but we're going to bring it on over to 452 minus 141, and I'm going to decompose it. So truly, this seems easy, but as soon as you start making this a 3, that's where it gets complicated. That's where we start breaking down, and truthfully, I had no idea what I was doing when I was just going over and regrouping and stacking and doing all that jazz. So we'll talk about that in a minute. In fact, let me make this a 3 right now. So if I was to decompose this, I would say 452, and I'm going to take each place value away at a time. So I'm going to take 100 away, which is 352. I'm going to take 352, and I'm going to take 40 away, which is 312, and 312, take 3 away, is 309. Okay, thank you, Amy. So 309. So eventually in grade 3, we are showing students exactly what they're doing. If we just jump right to here, yeah, your kids are going to get the right answer. So if that's really what you want your students to know and your kids to know, that's fine. But our job as a teacher, as an educator, is to truly show students why this works. That's our job. So our job is to show them why it works. And then the reason why I'm doing this for you is so that you can then see why it works and why it's so important not to jump to this when they get home, but to really value their strategies that they learn in school. So once we start kind of talking about decomposing, then finally in grade 4. Now granted, please keep in mind, how old are students in grade 4? Just think about that. They are still babies, right? They're not that old. So it's okay to wait to show them the stack and carry. So if we had, and they go up to multi-digit numbers, so let's just say 1,456, and they took away 312. They start seeing this eventually in grade 4, because they know that, oh, I remember this. This is 300s, this is 110, this is 2 1s, and I'm taking it away. So I have 6 1s, 5 10s minus 110, 400s minus 300s, and 1,000. Okay? So this strategy works in grade 4 beautifully, and they know what they're doing if all of these are really articulated and we don't jump the gun. Okay? We can't jump the gun and just teach students procedures, because if we do, this is going to get a little dicey in grade 4. All right, last but not least, let me show you how to regroup. So when regrouping comes into play, like 2,474, and I'm taking away 365, okay? So automatically, and I can guarantee that a lot of students see this as 5 minus 4 and put 1. we need to make sure the students are thinking back to what was the action that we're doing. We're starting with 2,474 and we're taking 365 away. I don't have enough ones to take 5 ones away, but I know that I can go over to my tens and break that up and help me and make 14 ones. So I can take a 10 away, and that 10 moves over to 10 little ones. So now I have 14 minus 5, which I can do, which is 9. 6 tens, take away 6 tens is 0 tens. 400s minus 300s is 100, and there are no thousands for me to take away. What's really cool is eventually students will start checking their work through addition, and that way they can see their misconceptions. If they do make a small little calculation error, it's really important for them to make sure that they see the connection. Sorry, this is getting messy. Between the total, our whole, and our two parts. All right, so hopefully that was helpful for you guys. Remember, our students need the foundational knowledge to be able to be successful in this skill of subtraction. It's not the easiest thing to learn. And so I just ask you and beg of you to be patient and learn the strategies of decomposing, and don't jump to the algorithm, because if we do, we're missing some steps. And I'm not going to say that all the time it's going, your kids might get the right answer. But if you're anything like me, and you just got A's throughout every subject in math, like every class you ever took, I didn't realize what I was doing. I was just following a procedure. But if you ask me to apply math, it was very hard for me. So I didn't truly become a mathematician until I became a teacher, and I had to defend why, right? So I was not ever good at math, even though I got A's in math. I could follow a procedure. I could follow rules, I could follow procedures, but I truly didn't understand why I was crossing everything out. So I really encourage you, if I learned this way, I would have been golden. All right, guys, remember, math is great. Math is beautiful. Have a wonderful Halloween. Be safe out there. And remember, subtraction is not scary, but remember, listen to the strategies your students are coming home with, and if you're not completely comfortable with them, let them try to explain it to you. All right?